Hey guys, Planet Everything here, and today I'm going to be discussing and today I'm going to be explaining how we find the distance from our Earth to other stars. So, this is a pretty simplified version, but I took astrophysics this year, and it's really kind of like my favorite class, but I learned this, and I thought it was really cool. I learned it like a couple months ago, but I think it's really cool, and I thought that a lot of other people would also like to know this, because it's just interesting. But anyway, if you've taken even a simple of a class like trigonometry, you should be able to pretty easily understand this. But right here, we have our sun. And that has a U, or 1 atomic unit. So what we've already determined that this is 1 atomic unit. We actually can use the same, about the same method to do this, by just knowing an atomic unit. Now, let's say we have a star way far out here. Obviously, they don't actually look like little stars, but that's what we're going to say for now. So what we want to be able to do is measure the distance from our planet to this star. Now, how are we going to do that? Well, we're going to take the measurement, or we're going to take 2 different pictures. One from here, one from here. This is different parts of our rotation around the sun. You know, not really that difficult to wrap your head around, but you've got 180 degrees difference between the two times, or these 2 pictures. So one's over here. This is one of the pictures. That's the second one. And in each one of these pictures, we can actually measure. We can measure the angle. We can measure the angle of this. We can measure the angle of this right here. Now, what we would do is divide that angle by 2. So you usually get something, either you get arc minutes, arc seconds, or they're smaller than that as well, but for this case we're not really going to need to know that. So an arc minute is if you took a protractor like this that has 180 degree little things, 1, 2, 3, 4, 5, 6, 7, 8. So it has 180 degrees. If you took 1 degree, this degree, and then you took that and split it into another 100, and then you split it into another 60. So 1 degree is equal to 60 arc minutes, and 1 arc minute is equal to 60 arc seconds. So with this unit of measurement being arc seconds, we can definitely figure out how far away this star is just by knowing this distance and the difference in angles that we have, because we have 2 different angles here. We could measure from this point in Earth's rotation and this point in Earth's rotation, so that we get 2 different we get 2 readings to tell us how far away this is from our sun. So to be able to do this, you're actually going to use this unit of measurement, 1 AU. So say that this star was, well, there's a few different ways to do this. You can either do like the extensive amount of math, like say like that's like 6 parsecs away, which it's just a lot of work to do that. For this situation, we're just gonna call this angle right here. The parallax angle. So P-A-R-A-L-A-X angle. And then that angle will just be right up here. There's not really that big of a deal. You can just take that angle and then put it into like, wow, crap, I don't really remember this math that well. But anyway, we take that parallax angle and we do trigonometry to find out how far away we are at this point, just by finding, you know, this and the hypotenuse. It's not really that, it's pretty straightforward, because if you know this angle and you know this distance, then you can divide that angle by 2 and divide this distance, this total distance by 2, which is just 1 AU, and then you can find out how long this distance is by using sine and cosine and tangent. So this actually only works on very specific stars, but there are not very many that you can actually do this on, because most stars are extremely far away, and this parallax angle is pretty much nothing on a lot of planets. So this distance between us and our sun times 2 is just not enough to determine how far away it is, because we just can't even get an angle from that. Our units of measurement just don't go that small. So we have to use something else called Redshift. And Redshift is, I can't really explain that well on here. Redshift, it gets really complicated if you have a star that's further away, because it's not too complicated, but you have Redshift, which is actually the wavelength at which, like if you have an object moving away from you, a wavelength emitted from that object, depending on how fast it's moving, will actually emit a red wavelength back at you, because of the wavelengths changed because of something called the Doppler effect. If you're moving really fast in a car, you're gonna have a compression up in the front, and you're gonna have like a spreading out behind, like a small vacuum behind. And it's the same with light, because if you're pushing really fast, really far, then you're gonna give off some light behind you, which is going to be slightly redshifted, and then using the redshift, we can determine the distance using Hubble's constant, or we can determine the redshift by using Hubble's constant to figure out how far away it is, just by kind of reversing the math. It's actually not that difficult, but Hubble's constant it changes actually, so it's a bit confusing. I don't know how to explain that very well, but essentially all you need to know, planets, like our planet, it's from our planet we can observe all planets are just moving away from us, and then from another planet it would look like all planets are moving away from us, and the further away they are, the faster they're moving away, which is what Hubble's constant tells us. And by using Hubble's constant, we can tell how fast they would have to be moving to be an X distance away, and to use to figure out redshift. Once we figure out our redshift wavelength, then we can figure out how fast they're moving and where they are. So yeah, that's pretty much it for this video. I understand probably the last little bit didn't really make any sense, but this parallax angle is kind of a really cool thing. If you're interested in physics or astrophysics, then you should definitely take that class if you're still in high school. And if not, then I'm sure there's some kind of learning website where you could learn all about this stuff. I think it's really fun. It's definitely my favorite class. But anyway, I know I didn't really go at all into the math of it, but you can use that information if you've taken trigonometry to figure out the actual distance between our planets and a star, just using the parallax angle and the distance between us and our sun. So yeah, guys, that's pretty much it for this video. If you liked it, please give me a thumbs up. Don't forget to subscribe, and also please share with your friends, because, you know, sharing is caring.